Assalamualaikum warahmatullahi wabarakatuh. Today I will present our research about Android application for presence recognition based on face and geofencing. The first is the introduction. The technology is currently developing very fast, wherein the industrial era 4.0, all the activities can be connected and accessed by using the internet and smartphone. Most companies have branches in various locations, which makes data synchronization becoming the main problem. In attendance systems, the system is demanded to accommodate each employee could make a presence at each branch. Currently, many of attendance system is in companies using a presence machines located at a particular location where each company or each employee must take turns to make absence both using biometric recognition such as fingerprints, QR code, or by using face recognition on the machine. Our research proposes a mobile-based attendance system using geofencing and face recognition in order to eliminate the extra cost and the queue process of the traditional attendance system. The use of the geofencing in the system is intended to provide a location boundary where employee can make a presence and face recognition for validation of employee to minimize the occurrence of fraud in attendance. In this system, every employee is required to have a login password and register their faces into the system. So the algorithm that we are proposing is the first one. We use the local binary pattern. Local binary pattern is a texture recognition that is also commonly used to represent face. LBP is often used in face recognition application because of its reliability and detecting texture compared to the other algorithm such as agent faces, Fisher face, or hard cascade. These figures specify the process of obtaining the mean E. E is the pixel that we want to process, and the resulting decimal label value of 8 bits can be expressed by the following formula, where LC is the intensity value of the central pixel, and M is the intensity of the neighboring pixel with index M. The second one, we use the K nearest neighbors or KNN. The K nearest neighbor algorithm is a non-parametric method used for a classification and regression. In this proposed system, we are using a combination of KNN and PCA, principal component analysis, in order to get a better recognition result. In this system, we are using the parameter K of 1, and in the search for the nearest neighbor using the Euclidean distance formula, where the x1 until xn and xj is xj1 until xjn are the vector features of the unknown sample and neighbor. The last one is PCA, or principal component analysis. This method provides an ability for data analysis and pattern recognition as a technique for data compression or data dimension reduction. PCA will reduce the complexity of space and time, and in this research, we want to create a better face recognition by using this algorithm. So the first major component has as much variance as possible because this transformation is defined in such a way. Each subsequent component has the highest variance, which may be under the constraint to the previous one. The resulting vector, which contain an observation, are unrelated orthogonal transformation basis sets. So for the implementation, the proposed system consists of two applications, which is the mobile and web application. The mobile application is use the main device for attendance and face recognition registration process, and the web application is used to monitoring the attendance data and also the employee geofencing settings. For this research, in the mobile application, we use React.js as the UI framework, SQLite as the internal database, And for web application, we use PHP. For the API, we use a Python language using Flash framework and Google Maps API, and also OpenCV for face recognition. The first one is employee geofencing setting. The geofencing is used as a virtual perimeter boundary of the attendance location where the employee can attend while the employee is at the location. It is created by using Google Maps API, and it is possible to obtain distance and estimate distance from point to point. So each employee will have its own geofencing with, and each employee could have one or more geofencing settings. So the geofencing is made with a maximum radius of 5 kilometers and a minimum of 100 meters from the center of the work site, and can only be made by the administrator on the web client. For the face dataset, every employee who will use the attendance system must register a photo of their faces into the system. Face photos are required for each employee, 10 photos where the photo shows the angle of the face. Each photo requires different face position from straight to camera position, approximately 5 centimeters to the right and left, then 5 centimeters to the face move up and down, and 5 photos of different facial expression. The face dataset stored in the server labeled by their employee number. So when the employee first open the application will check the employee dataset. If is it not exist, then the application will make the employee to take their photo of 420 point 420 pixel dimension and then send it each photo to the server. When it's done, the verification and attendance process can begin. In this process can consist of several parts that I will be explained later. And then attendance process. This picture is the global process of the application, where when the employee open the application will try to get the personal data. The personal data is consists of their employee number, name, address, and etc. And also there's geofencing settings. And then when the employee is try to make an attendance, the application will check area, GPS, and geofencing. As I said before, the one employee can have one or more geofencing settings. So the application must validate the current address one by one to their own geofencing. After it is validated, the application will try to capture the image of the employee and then send the picture to server for recognition. After the recognition process is done, the server will reply with the status true or false, and then the attendance is complete. For face recognition process, the image dataset that have been cropped is converted into grayscale and denoising using a Gaussian filter, the filtered picture, and then divided into two parts, which is a training and testing image. Both images are sent to the PCA to convert into a lower subspace. Then the training image result of PCA is classified using KNN. This is the experiments and result. The first one is, in this research, we are trying to comparing the combination of KNN algorithm and PCA with the result of LPPH algorithm and also neural network algorithm. Both LPPH and neural network algorithm, we are using a library from sklearn from Python language to make these experiments. And in this first experiment, we are trying to test the accuracy and time result based on the face dataset. The first test case is using 200 face dataset, and in this test result, the KNN classifier accuracy is have a 90% better than the others classifier and have time of 1.5 seconds. And the second test case is we are trying to get higher face dataset, which is 350 face dataset. In this result, the accuracy in KNN classifier and neural network classifier have a higher accuracy than before, but with slower time speed. And the time speed that is needed is 1.8 seconds. And the last one, we are trying to using a 500 face dataset test result. The accuracy of KNN is 90% and the neural network is increasing into 85% with the time 1.9 seconds, and for the KNN is not so much different, which is 2.0 seconds. And the second experiments we are trying to testing the result of time and accuracy by comparing the current address and GPS address that is shown in mobile application. In this test, we are trying to get a better understanding about the time and the accuracy when the geofencing validation is made. In this test, the test number 1 to 5 is use the same building, which is in building A, and the test 6 to 10 use different building, which is in building B, but still in the same address, because GPS results were affected by several constraints, such as cellular network in AGPS, distance to BTS, walls, and etc. So for first test case inside the building, in the test 6 to 10, there are several differences with inaccuracy within building A. This could be made by slower connection, and the second test case is outside the building. The accuracy is 100% and the best time result is 1.89 seconds. The GPS accuracy result in outside building test was more accurate compared to the inside building result. The longest time need to authenticate was 3.41 seconds and the fastest time was 1.96 seconds. So the conclusion is this paper has created a mobile-based attendance system using geofencing and face recognition. The system captures image from the employee when the employee is inside the geofencing area. Face data will send to the server for recognition using PCA and KNN with the best result of 90% accuracy and the processing time of 1.5 seconds, which was better than LPPH and neural network recognition. By using the geofencing, the employee does not need to wait and queue in the attendance machine, which is better than the other system. The fastest time to the complete present is approximately 3.4 seconds, which include a geofencing authentication and face recognition process. This is our reference that we use, and thank you.